This is a lecture on deep neural networks. The neural networks typically organize their neurons into layers. When we collect together linear units having a common set of inputs, we get a dense layer. So, for this example, let's just use a pointer. So, this is a dense layer, and the input is common. X0 and X1 is common for this dense layer. So this is a dense layer of two linear units receiving two inputs and a bias. So a neural network will have these dense layers, but having these dense layers is not enough, because these dense layers will always produce a linear relationship. The model should model something which is nonlinear, something like this figure out here, which is a nonlinear relationship. And for this, we introduce the activation functions. The most common one is a rectifier function, which is very simple, which is max of 0 comma x, which means that if it is negative, it becomes 0. If it is positive, then it stays the same. So now what we do is that we combine the rectifier function with the linear unit, and we get a rectifier linear unit, or the ReLU. So applying a ReLU activation to a linear unit means the output becomes max of 0 comma w star x plus b, which is drawn in the figure right here. So this is a very fundamental component of a neural network. Now, a complex model can be done by stacking these dense layers. Now, there is a concept of a hidden layer, which means that it is neither an input layer nor an output layer. It is hidden in between the input and the output. So here we have a stack of dense layers, and these two are the hidden layers. Now, how do we model it in Keras? So modeling in Keras is very easy. You have an input shape which is 2, because there are two inputs. The activation is ReLU, and there are 4 neurons, so you have 4. In the second layer, you will have 3 neurons, and it's stacked together with this, and the activation is ReLU, and the last layer is the unit 1, because it has only one neuron. Now, this last layer node has no activation function. Why? Because we are modeling a regression task. If we had modeled a classification task, this would have had an activation function, which we would discuss later. Thank you so much. Hope you understood the concept. Bye.